This chemistry, you got the aniline here, aminobenzene. That is a one way you can write down the nitrous acid, but you can also do that with a sodium nitrite and HCl. So you're gonna see this or that. We can easily use either forms. That basically convert an amine to the diazoxide ion. And then when you make the diazoxide ion, you can do also different things. But the reagent we use is a Q plus bromide. So these are sand-mine reactions. It's an easy bromine is going to replace in the N2, so you get that. So it's pretty simple reactions. The next one here is kind of the things you got the amines and the ketone, right? So easy that imagine that the nucleophile attack the electrophile. So you're gonna get the tetrahedral intermediates, but this proton transfer to the nitrogen to the oxygens. That makes a terminal amine. Hydroxyl groups will be protonated. That makes it water sitting on there. Nitrogen lone person coming in and kicking the waters out and losing a proton. That basically makes an amine. This process here, just me working it out. If you're familiar with that, you can skip that and basically make an amine. That's okay. Right? Amine gets reduced by the lithium aluminum hydride, but it can be done with the sodium borohydride as well. That reduces the amine to the amine. So this is just nothing but without combination. This is the carboxylic acid right here, just a varying chloride. I mean, that's something that we're going to go over again next chapters, but we know that the thionyl chloride can replace the hydroxyl groups with the chlorine. So that's the way you make the acid chloride. You treat the ammonia with that, basically you make an amide. So process making amides replacing the chlorine, but it's not just directly come and go. It actually goes through the tetrahedral intermediates. That's something that you're going to be seeing it in the next chapters. Amine makes an attack to the carbonyl because carbonyl is electrophile. That always happens. That makes a tetrahedral intermediate, just like this apple did. But difference between ketones and aldehyde, the carboxylic acid derivatives, it has a leaving group, chloride. This one does nothing leave there. Here, chlorine can leave. So that's why this oxygen coming in and they keep the chlorines out. And of course, proton of the amine goes away to solvents. So you make the amide. So that's the difference between this process and that process. That's why I told you many reactions in chapter 18 does not work well on the carboxylic derivative. We're going to talk about it in next chapters. Because they have a link. This amide, the third step is a bromine with a sodium hydroxide. Once you see that with an amide, then you should imagine that that's a Hofmann rearrangement. That will basically get rid of the carbonyl and amine put together directly, so it makes an amine.